So we are going to start with the final product of the pre-work, which is a model of steady-state laminar flow of water in a pipe. Here you can see the velocity graph. So we want this to be a better model of our sampling system for the eNodes. So the first step is we need to change the material inside the pipe from water to air. To do this, we will go to Component and then Materials. By right-clicking on Materials, we can go into Add Material from the library. The library will appear on the right, and we can go into Gases and select Air. By double-clicking on Air, air will appear on the left, at which point you may select the pipe and replace the water in the tube with air. And we'll double-check to make sure that water is overridden. The next step is to change the calculations from steady-state calculations to time-dependent ones. So we will right-click on Study, go down and select Time-Dependent. We will now delete the stationary calculations. And so we want to double check that all of the governing equations have been switched to time-dependent ones. So we'll click on laminar flow. And we will double check that all of the equations are time-dependent. Looks like we're all set. Our next step is to add the diffusion of the scent through the pipe. To do this, we will go up to Component and right-click to select Add Physics, which will appear on the right-hand side. We can then select Chemical Species Transport and then Transport of Dilute Species. This will now appear on the left-hand side. To set up, ensure that the domain is the entire pipe. We now need to change convection to velocity field SPF to ensure that the two physics will be coupled. We will now switch the material to air. It's time to add the inflow and outflow, which you will remember from the laminar flow. The inflow is the left-hand side boundary. And the outflow is the right-hand side boundary. The concentration of scent will be coming from the left-hand side boundary. In this scenario, we will set the diffuse species to be 1 mole per meter cubed. We now will select multiphysics, and by right-clicking, we see that we can combine reacting flow with dilute species. This couples the laminar flow and the transport of dilute species. We now need to generate a mesh. And as you can see, it is the same as the one from the laminar flow. Now going into the time-dependent tab, we need to change the maximum time from 1 second to 0.2 seconds, as this diffusion will take place very quickly. And each step will be set to 0.01 seconds. And now we will compute the results. This may take a little while. If you want a quicker calculation, you can set your mesh to a coarser setting. And skipping ahead. Great, so now we have our model. Here we will look at the laminar flow's dependence on time. And as you can see, the laminar flow establishes very quickly. But what we're most interested in this model is the concentration over time. So to look at this, we'll make a new 2D plot, and we will select a new surface. In this surface, we will set to concentration of C. And we will generate this plot. Now we can animate this plot and look at the concentration of C's dependence on time. Diffuse species C quickly fills the pipe. Now with this model, we can quickly change the geometry of the pipe and examine how different geometries affect the boundary layer and the rate of diffusion by C.